Hi students. Today we are here in this lecture, computer networks. These are the previously discussed topics: network model, OSI. We have discussed 7 layers of OSI. Then further we have seen encapsulation, decapsulation, and other things related to OSI. So today in this lecture we'll be discussing about TCP/IP model and some of the addressing modes. So here we go. TCP/IP protocol, it was like developed prior to this OSI model, and therefore the layers in the TCP/IP model are exactly not the similar the one we have in OSI model. So the original one was having 4 layers, and now the TCP/IP that we use is a 5-layer model, and these are more or less similar with the OSI layers. And we all know that in OSI we have got these 7 layers. So the left hand side diagram, that is A, has 4 layers. So this is what we were having earlier TCP/IP model. Now we are having 5 layers. As you can see, physical, data link, network, transport, and application. So it is very clearly visible that now the application layer in TCP/IP model includes the all the 3 layers that we were having in OSI model. That is the session, presentation, and application. So this is evident from the diagram. So this is what we are like having the earlier model that we were having of TCP/IP and the current model that we use. So these are the 5 layers, these are the 7 layers of OSI model, and here are the 5 layers of this TCP/IP model. So as already communicated to you, the 3 layers in the OSI model are now said to be as 1 layer, that is the application layer of TCP/IP model. Yes. Now, if we like talk about this TCP/IP thing, so there are a lot of protocols that can be discussed here, and right from this stage, like physical layer, data link layer. So for physical data link layer, we have got certain protocols that are there. We'll be studying in the subsequent lectures. And if I talk about the network layer, we have got primarily over the internet thing, we have 4 protocols. So they are RARP, ARP, ICMP, IGMP. What do you understand by the term RARP? This is very important to understand. I believe out of all the protocols that are mentioned here in this slide, I believe RARP and ARP is the most important one. And when I'm saying it is an important one, obviously I'll emphasize more on this thing, RARP and ARP. So RARP stands for Reverse Address Resolution Protocol. ARP stands for Address Resolution Protocol. See, in last lectures, probably what we have seen is we have certain addresses to like locate our machine. So these addresses are like categorized in 2 things, one being the physical address and another one being the logical address. So if I talk about the physical address, what is the physical address? Physical address is basically the address of the machine. Say for example, I have my device laptop, or for that matter, I am having my device mobile phone from which I am communicating. So all the devices have their own unique address that is we called as physical address. We also called it as MAC address, and this is like imprinted on the network interface card. Like the moment we buy a device, we purchase a device, that is there with us because it is imprinted by the manufacturer. So this is one thing about the physical address. Logical address is whenever we are on a network, so our network provider, our internet service provider gives us the one address particularly dedicated for our machine. So that is called as the logical address. Now there is a basic difference between physical address and the logical address. Physical address is something which is generally very difficult to change, or rather I should say it doesn't changes. And as far as logical address is concerned, logical address keeps on changing. The moment I am connected to the other network, address gets changed. So this is the concept of physical address and logical address. Now what does RARP has to do in this? See, before teaching you RARP, let me give you small analogy. Say, for example, somebody's name is, say, for example, you can take my example. I am Saurabh Anand. And say, for example, I am recognized in my like professional world or in my organization as Saurabh Anand. But quite possible my home nickname or by the name I am pronounced at my place, my residence, by my family members or my close one is different. So there can be a situation when one of my close family member, he interacts with someone who is working in my organization, and he says that how is ABC doing, or like how is ABC working in your organization. Then that colleague of mine can probably ask, I don't know about anything about ABC, could you please clarify a bit. So this is the confusion we have when we are following this concept of two addresses, physical and logical address, and actually both are required. So what happens is at times we are on a network, knowing one address, we how to get the information about the other address. So RARP probably helps in that. So what does RARP does? RARP's job is, if somebody knows the physical address of that machine, if somebody knows the physical address of that machine, so it is the responsibility of RARP protocol to map that physical address with the logical address. So RARP finds out the logical address for that machine or for that device. What does ARP do? ARP does exactly the opposite thing. Knowing the logical address of a machine on which a net, on whichever network it is connected, it tries to find out the physical address of that machine. So this is the job of RARP and ARP. And these protocols are, as you can see in the slide, these are used at the network layer. Now, in network layer, if we see, there are two more protocols. One is ICMP and another one is IGMP. ICMP stands for Internet Control Message Protocol, and IGMP stands for Internet Group Management Protocol. So if I talk about ICMP, ICMP is a very simple protocol. Basically, the job of this protocol is to check whether there is any network communication issue or not. That's it. Whether whatever like information you are sending, whether it is reaching to the destination in a timely manner or not. So this is the job of ICMP. As the name indicates, it is controlling something. It is controlling the messages. It is keeping an eye on the messages. See, obviously, when I have sent something, say for example, I have sent something on the courier, and I want to keep a check whether it is on the right track or not. So I have been given this tracking ID. So I track it. I am somewhere or the other controlling it. So exactly, if I say I am controlling it, I am not controlling it. Like I cannot ask the courier people to get it delivered on this time only. But ICMP does that. So this was like a correlation I was trying to establish. But this is the job of ICMP. ICMP checks for any discrepancy. ICMP checks, or rather, ICMP diagnoses the issues if there are any. What does IGMP stands for? IGMP is basically Internet Group Management Protocol. So basically, what it does is, if you have to transmit some information to in a multicast group, probably to the adjacent devices, then you can use IGMP. See, whenever we talk about the network, we talk about three terminologies. One is unicast. Unicast is something I need to talk to someone, so I have to like one-on-one connection I have to establish. That is point to point. If I talk about broadcast is something I'll simply say one thing, and that is heard by all of you. So this is broadcast. Broadcast relieves one from saying individually the same message again and again. I'll give you a small example. We all have this Gmail thing of GLAU. So quite possible, you may receive a message from this written there, GLAU all. So what happens is, somebody has sent the message and it has broadcast that message to everyone. So this is the concept of broadcasting. When multicasting, quite possible, I am your teacher of a computer network, so I might make a group of you people, and instead of like sending it to all, or rather I should say, instead of sending it on GLU all, I'll send the information on that particular small group that is dedicated for computer networks. Okay. Now, when we talk about transport layer, like this is something which needs to be discussed in depth, and probably that we'll do in the subsequent lectures. Okay, again, like if we talk about the TCP and UDP, the basic difference is TCP is connection oriented and UDP is not. So, what do you understand by the term connection oriented and not being connection oriented, or rather, I should say connectionless? So connection oriented means that whosoever like I am communicating or I will be communicating like source to destination. So prior to transmitting something, I try to establish the connection. So this is the concept of connection oriented. So obviously when I am like taking so much of precaution, or I am taking so much of effort, so what I am doing is I am making like it to a certain extent, I am making this connection as more reliable. On the contrary, UDP is not that reliable. And if I talk about SCTP, SCP stands for Stream Control Transmission Protocol. So basically SCTP is a combination of balanced combination of TCP and UDP. And SCTP says like SCTP is basically for more of sophisticated applications, which requires both kind of things. They want a mix of like maybe connection oriented, connectionless. So this is it regarding the SCTP. We'll study in depth. Don't worry. See, when I am saying that we'll study in depth, I really mean it, because in the subsequent lectures, this is the like demand. We have to like follow protocol by protocol. Okay. Now, if I talk about application, application is basically all about the presentability, the encryption, and the other things. So there are few protocols that are like discussed here. SMTP stands for Simple Mail Transfer Protocol. Whenever you are sending some information over mail, so you have to like follow this protocol. FTP stands for File Transfer Protocol. Whenever I want to like establish a connection, I have to transfer some files. So we can do this thing. Even what I can do is by using a simple command, I can transfer my data to my like laptop, or I should say I can access my cell phone data from my laptop only. So that's very simple. You have to simply start one services of your mobile device. There you'll be having this FTP address. That FTP address needs to be put here in the browser of your laptop machine, and you'll be able to access your device, mobile device. Now, what is HTTP? HTTP, we all know this is a hypertext transfer protocol. Basically, for accessing any website, we have to follow this HTTP. Nowadays, we are having HTTPS. S stands for secure. So it is more secure, like banking and other things where the like information needs to be more secure. So we tend to use HTTPS on domain names server system. This protocol, this is like very simple. What it does is it translates a domain name into some logical entity. Say for example, I've got this gla.ac.in. So on a network, it is not recognized by gla.ac.in. It is for our convenience. We are using the nomenclature, but ultimately, like it has to be get converted into one logical entity. What is SNMP? SNMP is nothing but the simple network management protocol. It manages each and everything. So basically, the job is to like organizing information about devices on IP network, and just in case if there is modification that is required in the device behavior, so this is dealt by SNMP. What is Telnet? Telnet is like a telecommunication network, rather I should say terminal network. So whenever I am on a system and I need to interact to somebody at a remote location, so Telnet is the one which helps us. So this is like a private network. This is very simple diagram that is shown here. So this is like one link is there, another link is there. There are 6 links that are connected to each other. Like what is the one thing that is being done at the physical layer? So physical layer is something which talks about node to node. So as you can see, A talks to first R1, then R1 talks to R3. This is the route they are following. R3 talks to R4, then R4 talks to link 6. So this is how in physical layer communication happens. Communication is like node to node. So this is your physical layer. Now, if it is written here, the unit of this is important. You should note this. The unit of communication at the physical layer is a bit. Bit by bit, information gets translated. So when we talk about the network, this is how the network information is flown at the data link layer. You can see again it is node by node, and the information is traveling in the form of not bit. Now what we have done is we have made the frames. So frame by frame we are transferring the data. Okay. Now what can we say about the this is a unit of communication at the data link layer is a frame. If I talk about the network layer is basically what it talks about. Instead of now node to node, this is the chain that we are observing from physical and data link layer to the network layer. We are having like it is host to host, like source to destination, destination to source. So this is how what we are like communicating in the form of datagram. So this is even more important. So the unit of communication at the network layer is a network or a packet. Now, if I talk about this at the transport layer, we know the communication takes place from process to process, like a process of a source and a process of a destination talks to each other. So again, we are transferring the information. So it is like traveling in the form of a segment. So we can note here the unit at the transport layer for the communication is a segment, or maybe we can say user datagram, or further we can say the packet. It depends upon the protocol we are using. If we are using UDP, so it is obviously user datagram. So now how it happens in application layer. Application layer is more of presentation. So finally a message gets flown from one layer to the another layer. So you can see the message D5, and again at the receiver end it is received as D5. Okay. So here it is a message, like simple, normal that we understand. Okay. Now 4 level of addresses are there. Like if we talk about this TCP/IP protocol suite, we have 4 different types of addresses that needs to be used. We have got this physical address. Physical address is used by 2 layers, that is physical layer and data link layer. And if we talk about the logical address is used by the network layer. And if I talk about the transport layer uses the port addresses, because we have to like specifically use the processes, certain processes that we have to use at the transport layer. And application specific addresses, that depends upon the application to application. So we use some specific addresses here. So these are the things that we'll discuss: physical address, logical, port, and application specific address. This is what I have already talked about. At the physical layer and the data link layer, you are using only the physical address. Rather, I should say physical layer, there is no addressing required, because bit by bit information is traveling. And again, you are saying you can see the unit of communication: bits, frames, datagram, segment, and the message. So this is like by the help of diagram, it is shown here. Like we have got a source who is having the address 10. This is the physical address I talked about. This is the MAC address, which is imprinted on the machine network interface card by the manufacturer only. At the time of manufacturing, this address gets imprinted. So 10 needs to interact with destination. How will it interact? So what it will do is it will first like talk to one central place, maybe a hub, and then this will further transfer the information to other devices. So one by one. So it reaches 2. So it checks, like the address here mentioned is 87, and this 2 is like having address 28. So it's not same. So packet is discarded, or rather 28 one says this packet is not intended for me. So I'll better discard this packet. Same goes here with the 53, because the destination address doesn't matches, so it is discarded. Yes, at the receiver end it is same, so it gets accepted. So this is what I was talking about. This is the general syntax of a physical address, the MAC address, that the address of the machine which is imprinted there. So you can see it's in the form of a hexadecimal. 12 hexadecimal digits are there, and it's a 6 byte address. So you can check that. So this is one example which is shown for the logical address, how logical addresses are used. So this is like communication is there. This is communicated to one router, and A is interacting. A needs to talk to P. You can see P this 20 and 10 are the physical addresses that we have used earlier, and now this A and P are the logical addresses which are provided by the network. So it has now first interacted with this machine. So as you can see, its logical address is not the same as mentioned in the this header. So it has to be P. So again, the information will flow in the other direction. Physical address gets changed. It first reaches here. So, but this is not the P. So they you can see they here the physical address gets changed. Then again the physical address change, and finally it will get to the destination. So this is how it's seen. See, this is just for like visualizing the things. You can check that. See, the physical address will change from hop to hop, but the logical address remains the same. Why is the reason? Because do not get confused. Earlier I have told you it is the physical address that remains unchanged, and the logical address remains changed. And here what it is talking about is exactly the same. See, remember I told you physical address is the address of the machine. When we are moving hop to hop, that hop is changing. So hop is nothing but a device. So that is the reason physical address is changing, and the address provided by the provider, the logical address, it is same. So that is why that is the reason why the logical address is same. So again, these are few diagrams. Now this is like application programs, and now we'll be using port numbers. So when we are saying port numbers, so transport layer comes into the picture. So say for example, via application layer, what is happening is via sender we have certain data, and layer by layer it is reaching. So this is the data. This is first layer, then second, then third, and finally it gets transmitted. So this way, that information will flow, and ultimately, application to application, it reaches. So it's very simple. Say for example, I have to mail something to another, my friend. I have to send some mail. So I am using my mail. That is one application program. He's using his mail. That is one application program. Or let me give you one more example. I am using Facebook. Somebody else, my friend, is using Facebook. So this is my Facebook. This is my Facebook. This is my friend's Facebook. So how Facebook to Facebook interaction will go? So it will flow in this direction. So this is the concept. This is the reason why this diagram is shown to you. The physical addresses change from, I think this is, oh, even the port addresses remain same. Yes, the reason why port addresses remain same is port addresses are on a particular machine for a particular application, for a particular process. So that's why, like, you cannot change that port also. Yes, if you happen to change the application, or if you happen to change the process, so quite possibly your port address will also change, and like it will change once you change the process. So this is like generally port addresses that we use. It's a 16-bit port address, like 2 to the power 16 port addresses are available. So like 753 can be one of the port addresses, and other common port addresses are 80, 25, and like this. So you can go through this. So I think we have covered what we discussed, like in the first slide, that we'll be discussing these topics. So we have covered this. Rest we'll see you in the next lecture. Thank you.